Alright, so we already learned what significant digits or significant figures are. We know that they are all the numbers that we're sure about in a measurement plus one estimate. So now we want to talk about how do we use these in calculations. So what are, first of all, the rules for determining how many significant digits there are, and second, we want to talk about how we apply that when we do calculations. So the rule that we use for determining how many significant digits are present in a measurement is called the Atlantic-Pacific rule. So if you think about the United States, I'm going to draw it as a square there. There's Florida. You have the Atlantic Ocean on this side, and you have the Pacific Ocean on this side. If you didn't know that, at least you learned one thing today. So the Atlantic side corresponds to a decimal being absent. So Atlantic, absent. The Pacific side corresponds to a decimal being present. So present, Pacific. So what do I mean by that? So decimal absent numbers would be like 12, 17,000. Anything with no decimal. Decimal present numbers would be 0.012, 12.7, or 10 decimal. So there is a difference in 10 decimal and 10.0. Numerically they're the same, but you'll see in a minute with significant digits being concerned, they are slightly different. So the first step in counting the number of significant digits a number has is to decide does this fall into the Pacific category or the Atlantic category. So if it falls into the Atlantic category, decimal absent, because the Atlantic Ocean is on the right side of the US, we'll start counting on the right side. If it falls into the Pacific category, meaning decimal is present, the Pacific Ocean is on the left, so we'll start counting from the left side. So the rule for counting is start with the first non-zero number, and once you start counting, don't stop. So when we're counting the number of significant digits in a number or a measurement, we never start counting with zero. We start with the first non-zero number, but once I start counting, then I count zeros. Okay, so once you start, you don't stop. And again, to decide whether or not whether you start on the left side or the right side, think about the Atlantic versus Pacific Oceans. So let's list out some numbers here. Let's just do 1700. 17.5, 1700.0, 0.001, 0.0010. I'm just going to list out some numbers. Okay? So let's go through and let's list the number of significant figures each of these numbers has. We'll start off with 1700. So ask yourself, is the decimal absent or present? So here it's obviously absent. So absent, start on the right side. I start on the right, I don't start with 0. I keep going, I don't start with 0. I hit 7, I start. So there are 1, 2. There are 2 significant digits. So if I look at this number, what this tells me is that I'm sure about the thousands place. I know that's accurate. And I'm estimating the hundreds place. So if I look at the next one, the decimal is present, okay, P, Pacific. I start on the left side. Start with the first non-zero number. So I say 1, 2, 3. There are 3 significant digits. So in this particular number, if these were measurements, we'll just label all these as grams. If these were measurements, I'm sure about the tens place. I'm sure about the ones place. I'm estimating the tenths place. So the next one, 17,000. or 1700.0, excuse me. Present, I start on the left side. Start with a non-zero number, 1. Once I start counting, I don't stop. So 1, 2, 3, 4, 5. There are 5 significant digits. Here, present, so I start on the left side. Doesn't count, doesn't count, doesn't count, 1. So there is 1 significant digit. Here, present, P, start on the left. Doesn't count, doesn't count, doesn't count, 1, 2. Once I start, I don't stop. There are 2 significant digits. Here, start on the left or right side. Hopefully you said right. Decimal is absent. So I start on the right side. Doesn't count. 1, 2, 3, 4, 5. So you'll see zeros in the middle of a number are always significant. Here, absent. So I start on the right side. Doesn't count, doesn't count. 1, 2, 3. So let's look at a few more. Let's look at 100, 100.0. So 100 decimal is absent, so there is 1 significant digit. 100.0, the decimal is present, so there are 4 significant digits. So those numbers are similar, but this number, you're telling me by writing it as 100.0, even though it's numerically equivalent to this number, you're telling me it's significantly more accurate. But here, decimal is present, so I have 1, 2, 3 significant digits. So that leads us to the next question. If I have scientific notation, how do I deal with that? So let's just look at 2.743 times 10 to the negative 8. So the answer is pretty simple. When counting significant digits, you ignore what comes after the times 10 to the negative 8. That doesn't mean it's not there. When you're doing the calculations, you still use it. I shouldn't have crossed it out. I'll just write ignore though. Ignore it as far as counting significant digits goes. So here I have 1, 2, 3, 4. 4 significant figures are significant digits. Okay, so hopefully it should not be too difficult to go and just determine simply how many significant digits or significant figures a number has. So I'll ask you to do that a couple of times, but that's not super useful. That's not a skill that's necessarily going to help us. The reason we do this is to be able to apply the rules for multiplication, division, addition, and subtraction. So now I want to talk about the rules for doing mathematical operations with significant figures. So I want to take a second and let's think about why this matters. Let's think about we're trying to find just the area of a piece of land, for example. Let's say we know it is a rectangular piece of land and we want to find the area of it. So length times width. So I know one dimension with a high degree of accuracy. So I know this side is 2.7438 miles. So if I say that, I'm saying that I'm confident about the 2743 and the 8's an estimate. So let's say the other side, it is 3.0 miles. I'm not very sure about that side. So I'm confident that it's 3 and I'm estimating the 0. So with one number that's highly accurate and one number that's not very accurate, we can't just type that in the calculator. So let's type, see what we get. If we did 2.7438 times 3, I get that number. I'll take it as scientific notation. So you're telling me that you're confident that the area of the land is 8.231 and you're estimating the 4. That's not the case because we don't know all those digits for the 3 there. So we have to have rules when we multiply and divide and add and subtract to account for that the numbers we're doing math with don't always have the same degree of accuracy. So let's start off with multiplication and division. So for multiplication and division, they have the same rule. Our answer should have the least number of significant figures or significant digits present in the problem. Okay. So anytime you're doing a multiplication problem or a division problem with a measurement, which everything in chemistry will deal with is likely a measurement, you need to make sure your answer has the least number of significant digits present in the problem. Let's look at what that means. So let's say I have 2.0 meters times 10.0000 meters. So let's pretend I need a calculator for this. You shouldn't, but let's just go ahead and do it. Typing in the calculator, you keep everything. We don't round off until we're done. So when we type in the calculator, hopefully you can do 2 times 10, you get 20. Okay? But now the question is, how many significant digits do I need? So let's count. 1, 2, 3, 4, 5, 6. This has 6 significant digits. This has 2 significant digits. So I keep the least number, so my answer should have 2 significant digits. So the way 20 is written, the decimal is absent, so I'd start on the right, only have 1 significant digit. But now if I put the decimal, I have 2 significant digits. Or I could write 2.0 times 10 to the first power. And don't forget your units. Meter times meters is meters squared. Okay? So let's look at some of the examples typed out in your notes. I'm not going to copy them down, so we'll go through them together on the calculator. The first one is 3.24 times 7.0. So we type that in, and on the calculator we get 22.68, and then meters times meters is meters squared, but that's not correct. We have to go back and think about how many significant digits I had. 3.24, we have the decimal present, so I start on the left. 3.24 has 3 significant digits, whereas 7.0 has 2 significant digits. So I need to round this answer to have 2 significant digits. So I do that by rounding to 23 meters squared. So the second problem, you have 100.0 grams divided by 23.7 centimeters cubed. So let's do 100.0 divided by 23.7. So your answer from the calculator is 4.2194 and some other stuff. Our unit is a gram over a centimeter cubed. So then go back and look at the problem. 100.0 has 4 significant digits. 23.7 has 3 significant digits. So I need to keep 3 significant digits in my answer. So I'm going to round that to 4.22 grams per centimeter cubed. So I know now we're focusing on this, so it's probably a little bit easier to think about. But go ahead and make the habit of, when you finish a problem, go back and double check your number of significant digits. So if we look at the next one, let's just pick another one. Let's do 710 meters divided by 3.0 seconds. Okay, so I type in the calculator 710 divided by 3.0, and I get 236.66 repeating meters per second. In 710, the decimal is absent, so I start on the right. I have 2 significant digits there. In 3.0, the decimal is present, so I start on the left. I have 2 significant digits there, so they're the same here, so that makes it a little bit easier. So I want to round this to 2 significant digits, so I round this to 240, okay, meters per second. So go back and double check after you round, make sure you did it correctly. Does 240 have 2 significant digits? The decimal is absent, so I start on the right, so yes it does. Okay, so I did 3 of those. I'll leave the other 3 for you to go back and do as practice on your own. So addition and subtraction is a little bit easier, the rule. So when you have addition or subtraction, we don't care about significant digits. For addition and subtraction, the answer should have the least number of decimal places. Present in the problem. So what do I mean by that? So let's look at a few. 12.74 has how many decimal places? It has 2 numbers after the decimal. 100 has how many decimal places? Well, let's just do 100.0. How many decimal places? 1. So 17.0004 has how many decimal places? 4. So these should be pretty easy. So let's look at the first one in the notes. It is 3.24 meters plus 7.0 meters. So when you add that together, you get 10.24 meters. So a meter plus a meter is just a meter there. So here I have 2 numbers after the decimal and 1 number after the decimal, so I have to keep the least. So I'm going to round to the 10th place, so 10.2 meters. Okay? So if you look at the second, you have 100 minus 23.73. When you do the math, you get 76.27 grams. But you'll notice 100.0 only has 1 number after the decimal. So I have to keep the least number of decimal places present in the problem. So I round that off to 76.3 grams. So go ahead and try the last 4 on your own. Go ahead and pause the video. When you start the video back, I'll have some mixed up problems that are multiplication, division, addition, and subtraction. Alright, so let's go ahead and look through these together. So a couple of steps we need to take for each problem. First, we need to decide which rule to do. So for the first one, we'll use the addition and subtraction rule. So the first step is just go ahead and get an answer. So do 17.4 minus 13.2001. You get 4.1999. So now I need to decide how many decimal places to keep because I use the addition and subtraction rule. So I see I have 1 number after the decimal, 4 numbers after the decimal, so I have to keep the least number. So 4.2 grams. So when we do that calculation, the 4.2 accurately represents, using the correct number of significant digits, how accurate these 2 numbers are. So if I look at the next one, I have 17.4 times 1,000. You get 17400 meters squared. That's just writing down from the calculator. Then I need to go back and think about how many significant digits do I need. So I count here, I have 3 significant digits. Count here, I have 1, 2, 3, 4, 5 significant digits. I want to keep the least number of significant digits, I need to keep 3. So here the answer, the way I have it written, is correct. If I were to write this as 17400.0, is that mathematically equivalent? Yes, but it does not represent accuracy in the same way, so it is incorrect. Another way to write this is 1.74 times 10 to the 4th meters squared. That's also perfectly okay. You have 3 significant digits there. So let's look at this problem. These are mathematically equivalent, but this number is far more accurate than this number, because this number is telling me I have 5 significant digits, so I'm more confident about more of the numbers. Here I only have 1 significant digit. Here I have 3 significant digits. So you'll get the same answer when you type it in, obviously, so we'll go with this one up here, but I need to round it to 1 significant digit. So I need to round it to 20000, or 2 times 10 to the 4th, meters squared, meters squared. I know that seems a little strange to round off that much, but this number right here is telling me it is not very accurate. It is fairly estimated because I only have one significant digit. So watch out for that. And don't just round that off to 2. Okay, we can't round off 20,000 to 2. And don't try and put a decimal there. If you put a decimal there, you've missed the problem.